So in this video, we're going to learn about lesson 2 of the Spatial Vis app called IsoCubes. So, we started in the first module, we learned about 2D rotations, but 3D, being able to draw in 3D is not trivial, and it took a long time for people to figure out. So, we have some 2D drawings, some very famous drawings and art, Egyptian art. But when we wanted to try to figure out how to draw in 3D, we had people using strings and all sorts of things to try to get the right proportion and the right scale from a 2D object to a 3D object and going back and forth between the two. So thinking in 3D, not just drawing, but thinking in 3D can be tricky as well. So what I would like you to do is imagine that you have a cube, okay? So you have an imaginary cube that you're holding in your hand, like a Rubik's Cube, okay? Hold it in your hands and place one corner, this is imaginary, place one of the corners on the table, so it's kind of skewed a little bit, and hold the other corner above the table. So now you've got your imaginary cube, and with your free hand, I want you to point to how many corners still remain in the air. So you've got a corner that's resting on the table, and you've got a corner with your finger on it on top, and then you've got these corners resting in the air. So how many corners did you point to? And I'll give you 2 seconds to figure this out. Okay, do you have a number in your head? Well, let's take a look. So the correct number is actually 6. I bet you a lot of you guessed 4. And that's hard to take a cube and rotate it and realize that it doesn't just have four, because that would be a different shape. It wouldn't be a cube, it would be like a rhombus or a triangular 3-dimensional shape. So you can see that visualizing and drawing 3-dimensional shapes can be challenging, but the more you practice, the better you can get at it. So let's introduce the concept of what an isometric drawing is. So an isometric drawing, it's a 3-dimensional drawing of an object, but it's scaled in a way where all angles of the axes, the X, Y, and Z axes, are all 120 degrees from each other, okay? And it's the most universal way that we represent drawings in 3D. In our 2D world, this is the best way to represent a 3D drawing, or the most common way, using isometrics. So we look at a cube, and you can see using the isometric grid paper, and where all the axes are 120 degrees apart, we can draw the cube along the length of the isometric paper. And so when you're using the app, you're going to be given isometric paper, and you're supposed to draw along the lines to represent the 120 degree angles between the axes. So one thing I want to mention about the length of lines in drawing 3D objects, okay? So here we have a 3D cube, and you can see that I'm pointing to the dimensions of the diagonals of the cube. So on the drawing, which line is longer? Is line A longer, or the distance between the two endpoints of B longer? So it looks a little skewed in this isometric, right? It looks like A, the distance between the two corners representing A, is longer. So actually on the cube, when you think about it, if you look at the cube down and look at the top view of the cube, it's a perfect square. And so the diagonals should be equal. But in the drawing, the line lengths are not really guaranteed to be the true scale of the lines, okay? So these are some properties that the lines along the X, Y, and Z axes will be true to scale. So when you're drawing on the isometric paper and you're drawing on those lines, they will be true to scale. But other lengths are not, so the diagonals that don't go directly on the isometric paper, they're not necessarily going to be true to scale. So there are other ways to draw in 3 dimensions. One way is using perspective drawing. So the top picture shows 1-point perspective and the bottom picture also. And it's basically where there's one focal point or converging point and all your lines line up with that, are aligned. So if you look at the top picture, you can see all these lines that are parallel to your buildings and your road, and they all end up at a common point in the center of the drawing, okay? So there's a lot of different ways that you can draw 3D images, but in this particular, in our Spatial Vis app, we use isometrics to represent 3D drawings, not perspective drawings. Okay, so in this particular IsoCube lesson, what you're given is on the bottom left, you're given the plan view. So this is the top view of the shape that you're going to end up drawing. So it's a two-dimensional view, and you're given some dots like the yellow and green dot, which help you orient how you want your isometric or 3D structure to look. And what those numbers on the top view tell you is they represent the height of each cube stack. So on the left-hand side by the yellow dot, you're 1 cube high, and then when you get closer to the green dot, you're 2 cubes high. So if you look to the right-hand side, you can see what your final drawing will look like. So if you're given this plan view on the left, you need to produce an isometric drawing on the right, and the number of cubes high are indicated by the numbers on the plan view. So one thing you have to know is that we do not draw crack lines. And so if you look at it right here, this is a single surface. So there is no need to draw this middle line. Same with this surface right here. There's no need to draw this middle line, and same with this surface and this surface. So when you have a whole surface, you don't draw all the crack lines, or you don't add the additional lines. So let's get into the app and show a demonstration. This happens to be assignment number 7 in the IsoCube model. So what we will do is, if you press play, you will see on the top right that the yellow dot is in the bottom left corner, and it's very similar to the example we showed, but it's rotated differently, and we have 1 cube high on the right hand side of the object, and then it goes up to 2 cubes high. And you can see that I'm all the surfaces, I'm not putting that center crack line, but when a surface changes its direction, then you need to put a line. So that concludes the lesson on IsoCubes, and you're welcome to get started on it in the app.